First, a reminder about differentiation. When we do calculus with root signs or often with denominators, you want to rewrite your function before you really do anything. So here we use that the square root of x is x to the power of a half, and 3 over x is rewritten as 3 times x to the power of minus 1, and the same thing here. Now we take a new line and find that y prime is 5x4 plus x3. The 7 hangs around. Here minus minus becomes plus. The 3/5 being a constant hangs around, and the minus 3 jumps down. The new exponent is minus 4, 1 less than before. Here fx is something to the power of 8. So f prime x is found by using the chain rule. The 8 comes down, so we have 8 times the inner function now to the power of 7 times the inner function's derivative. And note the brackets, because you want to multiply by all of the inner function's derivative. To differentiate e to the power of 2x, you use the chain rule, so it's e to the power of something. To get e to the power of 2x times 2, a factor 2 popping up. Similarly, ln 3 is just a number, so you can do it in exactly the same way. ln 3 is just an element of a set of real numbers. This guy is e to the power of minus x. So here we get a factor minus 1 popping up. This guy is x to the power of minus a third, so the minus third comes down, and the new power of x is minus 4/3. Please do not use mixed form. Thanks. Constants on their own differentiate to 0. To differentiate 3 to the power of x, you can cheat, so as to say, so as to speak, and use the formula booklet. Or more systematically, you can rewrite your function so that it has a base e. Okay. Now we use this as up there. So y prime. So notice that effectively speaking, I'm taking a new line, of course, when I find y prime. Y is definitely not the same thing as y prime. And when I give the answer, I'm going to use that this is 3 to the power of x, because 3 to the power of x, we just saw a couple of seconds ago, was that. So if a is b, b's got to be a. Last term we saw that ln x differentiates to 1 over x, a result I hope you know by heart. This term we saw that if you use absolute value bars there, you can say that it's valid also for negative x, because then the thing you're taking ln of is positive and things are okay. Here I didn't use that because everything here is positive anyway, but squares are non-negative. Anyway, you have ln of something, you differentiate it using the chain rule, and you get 1 over something times all of the inner function's derivative. So when you differentiate the ln of something, you get something's derivative over something. Here you have 1/7 copy of e to the power of 7x. So since e to the power of 7x differentiates to 7 e to the power of 7x, here you just end up with e to the power of 7x. So 1/7 is a number, not on its own, so it hangs around. On the other hand, here 4x cubed plus 2 is not a number. So here you need to use the quotient rule. So you take the bottom function times the top function's derivative minus the bottom function minus the top function, sorry, times the bottom function's derivative, all divided by the bottom function squared. And then similarly with x times e to the power x, there is a multiplication sign, so you need to use the product rule to find the derivative. So constants on their own differentiate to 0, constant not on their own hang around, and otherwise be careful. Here we wish to find and classify all critical points of a function g. Basically, critical points of a function are points at which the derivative of a function is 0. So here g prime x is minus 12x cubed plus 96x squared plus 276x minus 360. So we can break out minus 12 so that's what we get if we factor out a minus 12. We could continue the factorization, but so what we want to do is to figure out when x cubed minus 8x squared minus 23x plus 30 is 0. So to solve this equation, we use factorization. And so recall from the autumn term that any integer root here needs to divide the constant term 30. Well, we spot that 1 works, because you get 1 minus 8 minus 23 plus 30, so 31 minus 31, so 0. So 1 is a root, so by the factor theorem we can divide our polynomial by x minus 1. And you can do that by fiddling around or by using long division. So remember that when you ask the question how many times does this go into that, you focus on the leading terms. X goes into x cubed how many times? X squared. Because x cubed divided by x is x squared. And so you do the long division, it comes out nicely, as you knew it would do, since we could divide by x minus 1. So, using this factorization, or this long division process, we get that our cubic polynomial is x minus 1, what we divided by, times x squared minus 7x minus 30. And now you want to, let's continue the factorization. Let's factorize this one as well. And this is what you get. So critical points are minus 3 and 1 and 10. And now we want to classify them, see whether they are local min or max points or neither. There are two ways of doing this. One is to use the second derivative. Alright, so you know, g prime x was this, and if we differentiate it, this is what you get. Then you take a new line, remember this is a two-step process, and evaluate the function g double prime x as at your 3 points of interest. It turns out that g double prime of minus 3 is negative, g double prime of 1 is positive, g double prime of 10 is negative. So in childish terms, minus 3 and 10 have negative mouths, sad mouths, whereas 1 being f and g double prime of 1 is positive, so here we get a happy mouth. And so minus 3 and 10 are local maximum points, whereas 1 is a strict local minimum point. Alternatively, you could have classified them, the critical points, by using the derivative. So you study the derivative just to the left and just to the right of each of the critical points. To do that, you factorize g double prime x the derivative as much as possible, and then I'm going to do a sign study, the Latvian style. So we draw the 3 lines, and here's going to be minus actually because of this minus sign, and then plus, minus, plus. And hence, remember now that the derivative of a function describes the original function's rate of change. So g is going to increase just to the left of minus 3, be flat at minus 3, and be decreasing just to the right of minus 3. So minus 3 will be a local max point. Similarly, 1 is going to be a local min point, and 10 will be a local max point. Finally, please give an answer. Please do that. Thanks. Find, if possible, the max and min value of gx is minus 3x to the power 4 plus 32x cubed plus 138x squared minus 360x plus 5 in the closed interval from 0 to 5. Now, the extreme value theorem tells us that a continuous function such as g has to take a greatest and least value somewhere in a closed and bounded interval. But let's now turn our attention to the more interesting question of calculating said max and min value of g in this interval from 0 to 5. So first you write down the candidate points, the points at which g might take its max and min value in this interval. You write down the endpoints as well as any critical points that lie in the interval over which you're maximizing or minimizing your function. So we need to find the critical points. This is our friend from the previous exercise where we found that g has 3 critical points, minus 3, 1 and 10. However, only one of these critical points lie in the interval over which we are maximizing and minimizing our function g. So we get 3 candidate points for where the function g might take these values. Now it's calculation time. Okay. So we plug in 0, 5, 1 into the function, the original function, because that is the function we are trying to max and minimize over this interval. So if you plug in 0, obviously you get 5, because these guys disappear. So g of 0 is 5. If you plug in 1 into your function, all of these guys, the x guys, becomes 1s. So you get minus 3 plus 32 plus 138 minus 360 plus 5. Okay, so here you got 170. So it's minus 190. So it's minus 188. And then the last one is g5. Okay, so you plug in 5 into the original function g, and we are gonna get some nice exercise in mental arithmetic. So here we can divide by 4 and then add 2 zeros. Yes, okay. So here we have like 325. So looking at these 3 values, 5, minus 188 and 3780, obviously the answer is greatest value is 3780 and least is minus 188. And again, please give an answer.